Okay, a lot of you turned in your work yesterday. Hang on. All right, a lot of you turned in your practice yesterday, which was great, but some of you didn't turn in work that was correct. So I want you to make sure that you understand how to do these problems, all right? Tomorrow you're going to have 3 questions on your quiz, just 3. I understand it's only 3, but some of these can be time consuming, so I don't want anyone to feel rushed or anything like that. You'll have 2 where you have to set up. So 2 where all you have to do is set up, and then 1 where you have to actually set up and solve. Find the whole partial fraction decomposition. So let's go through the steps to do that. Some people ask for extra practice. These first 3, they're only for setup, but if you want to go ahead and solve them, you can. I can post the answers later with everything worked out so you guys can see that, if that would be helpful. But when I look at this first question, you have to go through the same process every single time when you do these problems. The first thing you want to do is factor the denominator. So when I factor the denominator, the first thing we look for is the GCF. Is there a GCF here? No. This is just a basic trinomial that you can factor. Tomorrow, everything will factor nice and pretty. It may not be the easiest problems you've seen, but they will factor. So what are the factors of negative 70 that'll multiply to give me negative 70, but add to give me 9?
14 and 5.
Positive 14, good. So x plus 14 and x minus 5. Now, it does not matter if you put x minus 5 first and x plus 14 second. That doesn't matter. But however many linear factors you have in the denominator is how many fractions you'll have. A linear factor will have an x and a possible value, plus or minus something, or it might have a coefficient, but it will have a variable in it. So how many linear factors do you guys see here?
2.
There's 2. So to get your equation set up, you have a as one denominator. So I'm going to put that with x plus 14. And then you have b, and I'm going to put that with x minus 5. Again, if you switch the order, not a big deal. But what you guys just did here, when you wrote this equal sign, you said that the left-hand side is equal to the right-hand side. That's not true right now. You have to make it equivalent. So I look here and I say, okay, a common denominator between these 2 is x plus 14, x minus 5. A has the x plus 14. What is it missing?
X minus 5.
The x minus 5. Do you guys agree I would multiply the bottom and the top by x minus 5? So now they have the same denominator, correct? Mm-hmm. So then you do the same thing with the second fraction. It has the x minus 5. What is it missing?
X plus 14.
The x plus 14. You would multiply it by the bottom and the top. So now if you notice, guys, this side has the same denominator as this side. That's what makes you be able to just cross off the whole denominator and just say, okay, here is an equivalent equation. 7x equals a times x minus 5 plus b times x plus 14. That is the setup. 2 of the questions will say, set up, do not solve. That is what I'm looking for. If you wanted to solve it, you would go ahead and you would set each of your linear factors equal to 0 and then plug in, which we're going to do a couple in a second. But if it says do not solve, this is what I'm looking for as an answer. Does everyone understand that? Mm-hmm. Okay, let's go to the next one. Each one of these ones that we're doing factors a little differently, and I was trying to give you guys different looks and stuff like that. So if I look here, the first thing we say is there a GCF? Okay, God bless you. What is the GCF between 3x cubed minus 27x? 3x, perfect. So I'm going to take out my 3x, and I'm left with x squared minus 9. Can I factor that more?
Yep.
So this becomes 3x, and then what?
X plus 3, x minus 3.
X plus 3x minus 3. Great, guys. So how many linear factors do I have here?
3.
I have 3. So how many fractions should I have? 3. So we say equals, I'm just going to put a, and then I'm going to put 3x underneath. Again, does not matter what order you do it. Then I have b, and then I'm going to put x minus 3. I'll put plus. And then c, I'll do x minus 3. Now, in order to finish our setup, we have to make the left-hand side equal to the right-hand side. We're pulling it apart. We're breaking it down. So now we have to say, okay, well, what would an equivalent or what would a common denominator be? A has the 3x. What are the two pieces it's missing?
X plus 3, X minus 3.
X plus 3 and X minus 3. Good. B has X plus 3. What is it missing?
3X and X plus 3.
Yep. X minus.
Oh.
Just your setup might be different than mine.
Oh, okay.
And then the C has the minus, so it's missing the 3x and the X plus 3. Correct? So now your answer to this would be 5x plus 1 equals, and you have A times x plus 3, x minus 3. You do not have to FOIL that out. You can just leave it. Plus B times 3x times x minus 3. And then plus C times 3x times x plus 3. And that, ladies and gents, is your answer for the setup. Now, how would you solve it? What would you have to go through?
You FOIL?
No, you don't have to FOIL it. What would be the three values that I have to plug in to solve?
Oh, U equals 0?
I set each piece equal to 0. So I would plug in 0, positive 3, and negative 3. And I would go through and I'd find the values for A, the value for B, and the value for C.
And then we just plug in for X?
Mm-hmm. Yeah, we're going to do a couple in just 1 second. All right, everybody all right? Okay, let's look at 3. All right, what do we notice about 3? GCF? 2x, good. So I'm going to pull out that 2x, and I'm left with 6 divided by 2 is 3, so 3x squared. 22 divided by 2 gives me plus 11, and then I have x. Negative 8 divided by 2 is minus 4. All right, this is a little different factoring than the first two we did because a is not 1. So remember, 3 times negative 4 gives me negative 12. What are the factors of negative 12 that multiply to give me negative 12, but add to give me 11?
X plus 12, X minus 1.
X plus 12, X minus 1. I was going through your submissions. A lot of you left your linear factors like that. If I multiplied X plus 12 and X minus 1, I'm not going to get 3X squared plus 11X minus 4. What am I forgetting to do?
You have to divide by 3.
I have to divide. I have to divide both terms by your A. So this is 2x. This is x plus 4. And this is 3x minus 1 because this 3 goes here. Everybody with me? All right, so how many linear factors do I have?
3.
I have 3 linear factors. That means I have how many fractions?
3.
3. Kira, question?
No, I was confused for a second. I didn't see the x next to the 2, so I was going to say.
Gotcha. So this is A, and I'm going to put it over 2x. And then B, I'm going to put x plus 4. And then C, was it 3x minus 1? Mm-hmm. Okay. So now we have to finish. We have to make sure that our equation is the same on the left-hand side as it is on the right-hand side. So your A fraction has the 2x. What are the two pieces that it's missing?
X plus 4, 3x minus 1.
Yep. X plus 4 and the 3x minus 1. Guys, again, if you put 3x minus 1 first, that's fine. The order doesn't matter, just as long as your A variable stays with A, B stays with B, C stays with C. So x plus 4 is with B. It's missing the 2x and the 3x minus 1. C has the 3x minus 1. It's missing the 2x and the x plus 4. So if all you're doing is setting up, you rewrite this as negative 5x plus 1 equals A times x plus 4, 3x minus 1.
Doesn't matter where it goes.
B, 2x and 3x minus 1. And then C, 2x and the x plus 4. That is your setup. And then to solve it, you would set each piece of your denominator, each linear factor equal to 0, and you would just evaluate that whole big long thing 3 times. Guys, when you evaluate, we're going to go through 3 questions here. I put an extra one just to give you a little extra practice. But when we evaluate, like in this case, if I plugged in x equals 0, what should happen to 2 of the 3 variables?
Cancel.
They should cancel every single time. If you have 2, when you plug in, 1 should cancel. You should only be left with 1 letter at the end where you're solving for A, for B, or for C. If not, you did something wrong, so that's a good thing to check. But questions? We all right? All right, let's go next ones. Okay, we're going to solve this. Do you notice it says find the partial decomposition of the following? It says find. It doesn't say do not solve. It doesn't say set up. So the first thing we do, like we've done every single time, is we factor. How is this one a little different?
It's negative.
It's negative. It's leading with a negative. So I'm going to take out that -1.
Divide all by -1.
If I divide everything by -1, all of our signs change. So 3x squared minus 13x plus 14. Right? A times C. 3 times 14 is 42.
42.
What are the factors of 42 that multiply to give you 42 but add to give you a -13?
Minus 6, minus 7.
Minus 6 minus 7. What's the problem here?
You have to divide by 3.
Yep. My A term is not 1, so I have to divide both of these by 3. So I have -1 out here, then I have x minus 2. And this doesn't divide pretty, so this becomes 3x minus 7. Everybody see that? Guys, what did I tell you at the beginning about linear factors? What do they have with them?
It's equal to 0.
Not that it's equal to 0. What should it have with it? How many linear factors do you have here?
2.
Why only 2?
Because -1 does not equal 0.
Not that it doesn't equal 0. It doesn't have an x.
Oh.
Right? It is true. -1 equals 0 is untrue, so you crossed it out. But it has to have an x value with it. So we have two fractions here. We're going to say equals a over x minus 2 plus b over 3x minus 7. So we're still in the setup phase. We haven't begun to solve it, but we're getting there. So now I look and I say, okay, what does my fraction have and what does it need? A has x minus 2. It needs 3x minus 7. B has 3x minus 7. It needs x minus 2. So now we have created an equation that is balanced. Negative x plus 7 equals a times 3x minus 7 plus b times x minus 2. Now, if you were asked to solve, that's it. You solved it. You set it up. I'm sorry. If you were asked to set up, I'm sorry. That's it. You set it up. But I want you to solve it. So now we have to figure out what A equals and what B equals. So how do I figure out, what am I plugging in to find out what those two things equal?
You set up equals 0.
I'm going to set each linear factor equal to 0. So x minus 2 equals 0. 3x minus 7 equals 0. So here x equals 2, and here x equals 7/3. Where did I get 7/3 from?
You add 7.
Add 7, divide by 3. Yes, you will have a fraction. Not a big deal. You guys will have calculators. You don't need them. But there are no decimals, so if you have a fraction, you have to work with fractions. It's not hard, guys. But when I plug in x equals 2, what should happen to one of the variables?
Cancel.
It should cancel. When I plug in 7/3, what should happen to one of the variables?
Cancel.
They cancel. So let's come over here. I'm going to start with the whole number. So I have -2 plus 7 equals a times 3 times 2 minus 7 plus b times 2 minus 2. So on the left-hand side, what's -2 plus 7? Yep, 5. Equals, what's 3 times 2? 6, and 6 minus 7 is?
-1.
-1. So I have -1a. Agreed?
Mm-hmm.
Now, the second piece, what is 2 minus 2?
0.
It's 0. So what's 0 times b?
It cancels.
It cancels. So we divide both sides by -1. And what does a equal? -5. Did we solve this yet? No. We're close. But now I'm going to do the exact same thing, but I'm going to come over here and I'm going to plug in 7/3. So watch, guys. You have 7/3. It's negative, right? -7/3 plus 7. I'm putting all of my whole numbers over 1 since I have a fraction. I like the way that it looks better. So I have equals a times 3 over 1 times 7 over 3 minus 7, right? Plus b times 7 over 3 minus 2 over 1. Questions on how I set anything up? Now again, this is very basic, simple math, guys. I have 3 as a denominator. If I wanted to change 7 over 1 to thirds, I'd multiply the bottom here by 3, right? What you do to the bottom, you do where?
To the top.
So 7 times 3 is 21. Excuse me. What's negative 7? Excuse me. Negative 7 plus 21.
14 over 3.
So 14 over 3 equals. Okay, so now let's simplify. Now, you can either cross cancel and see that 3 goes into 3 and cancels out. But what is 3 times 20? 3 times 7?
21.
Divided by 3 is?
7.
7. And then 7 minus 7 is?
0.
What happens to this?
Cancel.
Excuse me. Now, in the second one, I want to change 2 over 1 to thirds. So I make this a 3. If you multiply the bottom by 3, you multiply the top by?
3.
So 2 times 3 is?
6.
What's 7 thirds minus 6 thirds?
1/3.
So 1/3 B. Everybody with me? Now, I want to get B by itself. So I'm going to divide both sides by 1/3, correct?
Yep.
Divide by 1/3. Divide by 1/3. Guys, when you divide by a fraction, same as multiplying by the... Yeah, so this is the same as multiplying by 3 over 1, right? 3 over 1. So B equals 14. So we decomposed our original fraction into 2 separate rationals, 2 separate fractions, and I found out what the 2 variables equal. So A, I'm going to go back to the original right here. I'm going to plug in my A and my B. So A is negative 5. So I have negative 5 over x minus 2 plus B we found was 14, right? So 14 over 3x minus 7. Now, if you have 14 over 3x minus 7 first, that's fine. You could write it 14 over 3x minus 7 minus 5 over x minus 2. Plus the negative is fine, but this is the partial fraction decomposition. That's the answer that I'm looking for.
How did you get 14? Did you divide?
Right here. We had 14 divided by over 3 divided by 1/3. So keep, change, flip.
That's 52 over 3, right?
Which reduces to 14.
Oh, 14.
Yeah.
Thank you.
All right, let's look at this one. Okay, it's a long process, I know, but we do the same thing every time. First place we look is where?
GCF.
GCF. What do they have in common?
2.
Okay, take out that 2, and I'm left with x squared minus 100. What does that become?
X plus 10.
X plus 10, x minus 10. Guys, how many linear factors do I have?
2.
Yep, I have the 2. So I'm going to break this down. And I'm going to say equals A over, doesn't matter, I'm going to put x plus 10 first. And then here I'm going to put B over x minus 10. Again, doesn't matter. Figure out what fraction has what it needs. So A has x plus, it needs the x minus. B has the x minus, it needs the x plus, right? This is an easier problem because there's no fractions that you have to deal with plugging in.
That's nice.
It is nice. So I have 17x minus 12 equals A times x minus 10 plus B times x plus 10, right? All right, so where do I get values to plug in for x?
Equals 0.
Set your denominator equal to 0. So 2 equals 0. No. X equals negative 10 and x equals positive 10, right?
Yep.
Okay. So let's solve this twice with x equals positive 10. And over here, x equals negative 10. Again, you could have done negative 10 first and positive, doesn't matter. So I have 17 times 10 minus 12 equals A times 10 minus 10 plus B times 10 plus 10. Left to right. 17 times 10 is?
170.
170. And 170 minus 12 is?
158.
158. Good. Equals. What's 10 minus 10?
0.
And 0 times A is?
10.
Cancels. What's 10 plus 10?
20.
20. And then 20 times B just gives me 20B. So divide both sides by 20. I saw yesterday in your practice, some of you left that as 158 over 20.
Can we reduce that?
You have to reduce it, yep. Some of you changed it to a decimal. We don't want decimals. 2 goes into 158 and 20. This would be what, 79 over 10? Okay, good. So we're going to do the same thing over here, but we're going to plug in negative 10. So I have 17 times negative 10 minus 12 equals A times negative 10 minus 10 plus B times negative 10 plus 10. That's a 10. I don't know what happened there. So 17 times negative 10 is negative 170 minus 12 is negative 182, right? Equals negative 10 and negative 10 is
Negative 20.
negative 20. So negative 20A. And then what happens with negative 10 plus 10?
They cancel.
This is going to cancel. Every single time that should happen, guys. So now divide both sides by negative 20.
Becomes positive.
So A, yes, becomes positive. Divide by 2. 91 over 10.
Yeah, 91.
Okay. All right, so now what do we do with that? What do we do with our A and our B?
You plug it
You're going to
back
replace A with 91 over 10, and you're going to replace B with 79 over 10. So I'm going to have 91 over 10 over x plus 10. And then I have 79 over 10 over x minus 10. Can I leave my answer like that?
No.
No. And I'll show you why mathematically in a second, but these 10s need to come down here. So this would be 91 over 10 times x plus 10. And then I have plus 79 over 10 times x minus 10. And somebody last period was like, why do you do that? Well, think about this. I have 91 over 10 divided by x plus 10, right? This is over 1. We keep change flip. So 91 over 10 times 1 over x plus 10. And then when I multiply through, I get 91 over 10 times x plus 10. So mathematically, when you divide those two, the denominator in the numerator moves to the denominator. Like this it up. Does that make sense? We okay? All right, I want to do one more. I want to go from start to finish. It's kind of a long problem, but I just want to get in the practice of doing it. So go ahead and copy the problem down. We're going to do the entire partial fraction decomposition. We're going to set it up, and then we're going to solve. So the first thing we look for is
GCF.
GCF. What do we have in common here?
X.
Take out an x. Okay, so this becomes 2x squared plus 5x minus 12. Yeah? All right. So let's factor. A times c. 2 times negative 12 is negative 24. What are the factors of negative 24 that multiply to give me negative 24 but add to give me 5? Yep. X plus 8. X minus 3. Good. Now what do we have to do?
Divide by 2.
I have to divide both by 2 because my A is not 1. So this becomes x times x plus 4 and then 2x minus 3. Question. How many linear factors do we have?
3.
3. We have 3. We have 1, 2, and 3. So how many fractions are we going to have?
3.
3. I have A, and I'm just going to put it over x. B, I'm going to put it over x plus 4. And then my C, what was it, 2x minus 3?
Yep.
2x minus 3. All right, everybody with me? We've done nothing different from the other 72 problems that we've done today. So now I have to see, okay, what does each fraction have and what is it missing? So A has the x, it needs
X plus 4 and 2x.
x plus 4 and 2x minus 3. B has the x plus 4, it needs the x and the 2x minus 3. C has the 2x minus 3, it needs the x and the x plus 4. Perfect. All right, so let's write our equation out, and then we're going to go through the process of solving. It's a long one, I know that, but you guys got this, no problem. So 3x plus 2 equals A times x plus 4, 2x minus 3, plus B times x times 2x minus 3, plus C times x and x plus 4, right? Now I'm going to solve this 3 times. How do I know I have to solve this 3 times?
Because you have 3.
I got 3 variables. I have an A, and a B, and a C. What are the numbers I'm going to use?
0.
Yep. You're going to set each piece equal to 0 in your denominator. So x equals 0. X equals -4. And x equals 3 over 2. I got 3 over 2 by saying move the 3 to the other side, divide by 2. What is going to be the hardest math that we're going to have to do?
The fraction.
The fraction. So should we do that first or leave it for last?
First.
Oh, good. I like it, Joseph. Good.
Get out of the way.
There you go. Get it out of the way. So we're going to solve this 3 times. We're going to solve it with 3 over 2, -4, and 0. So let's start off with x equals 3 over 2. Get it out of the way. So 3 over 1 times 3 over 2 plus 2. Agreed, everybody? Okay. So I have a times 3 over 2 plus 4 over 1 times 2 over 1 times 3 over 2 minus 3 over 1. Questions on how I plugged any of that in? Same thing, say plus b. Again, we're using 3 over 2, so 3 over 2 times 2 over 1 times 3 over 2 minus 3 over 1. And then c is 3 over 2 times 3 over 2 plus 4 over 1. All right, everybody look at that. All we did was plug in 3 over 2 every single time we found an x. So now I'm going to go through and just simplify. When you're multiplying fractions, guys, you multiply the numerator. 3 times 3 is 9. 1 times 2 is 2. Plus, this is 2 over 1, right? What's the common denominator between 1 and 2?
4.
You could use 4,
Oh, yeah.
but you want to just use 2? If I make this a 2, I multiply 1 times 2, then 2 times 2 is 4. So this becomes 4 over 2. So when I add those two together, 9 halves plus 4 halves is 13 over 2, right? So now let's go through and simplify all of these gross problems. Ay, ay, ay. Well, look here. Multiply your fraction. 2 times 3 is
6.
6, and 6 divided by 2 is...
3.
So this becomes 3 minus 3, which is 3 minus 3.
0.
0. And 0 times anything is...
0.
So this is all going to cross out. All right, let's go over here. Right here, what's 2 times 3? 6 divided by 2 is 3. 3 minus 3 is
0.
0 times anything is...
0.
Oh, look, this all crosses out. So now I come over here. Common denominator, guys. Got to simplify inside the parenthesis first. So if I multiply 1 times 2 and I multiply 4 times 2, do you guys agree with me? I get 8 over 2. If I have 3 over 2 plus 8 over 2, that gives me 11 over 2, right?
Could you multiply like with 2 3 over 2s or no?
No, you need to simplify inside first.
It's not first.
Mm-hmm. So now I multiply 3 over 2 times 11 over 2. Well, 3 times 11 is 33. So I have 33 over, what's 2 times 2? 4. And the letter was C. That whole thing simplified to just that. Because when you guys plug back in, what happens to 2 out of the 3 things? They're going to cancel. So now you guys are going to divide both sides by 33 over 4, which is the same as multiplying both sides by 4 over 33, the reciprocal. So 33's cancel, 4's cancel. You get C equals, you could just multiply across, or you can cross cancel. Say 2 goes into 2 once, and 2 goes into 4 twice. So 13 times 2 is 26 over 33. All right, now we're going to go to the easier ones. We did x equals 3 over 2. Now let's plug in using x equals -4. So x equals -4. All right, so we got the whole problem again. We have 3 times -4 plus 2, right? Equals a times -4 plus 4
times 2 times negative 4 minus 3 plus b times negative 4 times 2 times negative 4 minus 3, right? And then plus c, negative 4 times negative 4 plus 4. Okay, so let's simplify. Left-hand side, negative 4 times 3 is?
Negative 12.
And negative 12 plus 2?
Negative 10.
Negative 10 equals. What's negative 4 plus 4?
0.
And 0 times anything is going to?
Cancel.
Cancel out.
Wow.
Simplify inside the parentheses first. What's 2 times negative 4?
Negative 8.
Negative 8 minus 3 gives me?
Negative 11.
Negative 11 times negative 4.
Positive 44.
So 44b. What's negative 4 plus 4?
0.
Times anything is?
Gonna cancel.
Yep. What's b equal?
Negative 10 over 44, but you can simplify.
Negative 5 over 22. Perfect. And now, thanks to Joseph, we're going to do the easiest part last. We're going to plug in what number? 0.
0.
So go back to the original. I have 3 times 0 plus 2 equals a times 0 plus 4. So 0 plus 4 times 2 times 0 minus 3. Then we have plus b times 0 times, what, 2 times 0 minus 3?
0.
2 times 0 minus 3.
Yep.
And then, we have c times 0 plus 4, right?
Yep.
Okay. So let's simplify left to right. What's 3 times 0 plus 2? 2
2. Yeah.
equals. What's 0 plus 4?
4.
4. What's 2 times 0?
0.
Minus 3.
Negative 3.
Yep. What's 4 times negative 3?
Negative 12.
Negative 12a. All right. What's 0 times anything?
It's gonna cancel.
What's 0 times anything?
That's gonna cancel.
Yep. What do I do?
Divide on negative 12.
Divide both sides by negative 12.
Then you'll-
So a equals negative 1/6. All right. Super long problem. We're going on 10 minutes right now. Yes, ma'am.
Isn't it 1?
Negative 1 over 6.
Where'd you get 1?
Because it's 0 plus 4, right? And then 2 times 0 is 0 minus 3, so 4 minus 3 is 1.
Well, you're multiplying these two together.
Oh, okay.
Yeah.
Sorry.
That's okay. That's okay. All right. Now we figured out what A, B, and C equal. So now we go back and we plug it up here. Can you guys tell me real quick, what did we find out A equaled?
A was
Negative 1/6. Thank you. What was B?
It was
Negative 5 over 22. And then C was 26 over 33. Okay. Just so it's easier for me to see. All right. So now I'm going to replace my A, my B, and my C. So A is negative 1/6, not 16, over X plus negative 5 over 22 over X plus 4. And then C is 26 over 33, and then 2x minus 3. The last thing I have to do here is what? Move your denominators down. Could you have done that from the get-go? Yes, you don't have to do that. So now you just have negative 1 over 6x. You can put plus a negative, or you could just say minus. You have 22 over x plus 4. And then you have plus 26 over 33 times, not a good 3, 2x minus 3. 2x minus 3. But what I cannot impress upon you enough, guys, is no matter how many letters you have, you'll never have more than 3 right now. I mean, in other math classes you may, but not right now. But when you have all these different variables and stuff, when you go to plug in x values, everything but 1 should cancel out. Yes, ma'am?
Can you go back down to B?
Sure thing. Right there, in blue. Everything should cancel out except for one. Yes, ma'am.
Are we gonna have one that long tomorrow?
Maybe, I don't know. But again, how many questions are on your quiz?
3.
3. How many solving ones?
1.
1. So even if you spent 25 minutes on one question, you still have plenty of time for the other 2. You have 2 setups and 1 solving. All right, 2 setups.
The solving could be like
One
this
solving.
with 3.
I'm not saying it is. I honestly, I don't know. It could be. But off the top of my head, I don't remember. I made the quizzes a while ago, so I don't remember. But I will post this right now so you guys have it. If you have questions, you can run by in the morning. Don't come in at 7:55 and ask me to do a problem. If you have a quick little, hey, something like that, that's fine. Yes, sir.
Can you go over the one with the 3/2 where we plugged in and all that type of stuff? Can we maybe do that again?
Sure.
Is that
Hold on.
fine?
Yeah, sure.